Okay, class, I am not here today, so I am going to record this lesson. Please make sure that handout 8.2 date 1 is in front of you so you can copy down these notes. If at any time you need to pause or rewind, feel free to do that as well. So what we're going to do today is I'm going to start 8.2 day 1. There is going to be 2 days of this, so if you're confused at first, we'll have another day to cover it, okay? But what we're going to be starting today is we're going to be using what's known as trigonometric ratios that you haven't heard of before to find missing ratios. Okay, so let's start off with just a little review. Okay, so the parts of a right triangle, when we're talking about what side is the hypotenuse, that's always across from your C value. Oh, why is it not working? Wait a second. Okay, give it a second, guys. Sorry. Okay. So across from your C or your right angle is C, so that's the side. Okay. It says what side is opposite to A. So angle A is up here. Opposite to angle A would be side A. Okay. When you're talking about what's adjacent to, that means the side that's next to. Okay. So in other words, we're looking at A. The side next to it would be B. Okay. I'm just going to rescan what I have, and we're going to now look at B. So opposite to angle B, go on the opposite side. That would be side B. And then what side's adjacent, that would be next to, and that would be A. Okay? So what I'm trying to get you guys to do is understand kind of where the adjacent, opposite, and hypotenuse sides are, and that's what we're going to use. Okay? So I'm going to walk you guys through this, and I'll show you a little more, guys, but this is kind of intro to trigonometry. There are 3 types of trig functions, which are known as sine, cosine, and tangent. Okay. So what we're going to do first is we're going to start with sine. Okay. So sine represents the ratio of the leg opposite to the angle and to the hypotenuse. Remember, a ratio is a fraction, so we're going to write it as a fraction. Okay. So if we're looking at sine of A, okay, what we're going to do first is we are going to go opposite to A, and that would be A over your hypotenuse, which is across from your right angle, and C. So sine of A is A over C. Okay. We're going to do the same thing, so if you want to erase what you have, but now we're going to look at its sine of B. So now our reference angle is going to be called angle B. Okay. So what we're going to do from there is we're going to go across, opposite, which would be B. Okay. And then your hypotenuse stays the same, it'd be C. Okay. Alright, so that's for sine. Cosine, it says the ratio of the leg adjacent to the angle to the hypotenuse. So we're going to now look at this. Okay, so this is going to be starting with cosine of A, because that's our reference angle. It's going to be the adjacent side, which is B, over the hypotenuse is C. Okay. And then for cosine of B, that's down here. Your adjacent side is next to, that would be A, over your hypotenuse is C. So it's A over C. Okay. And then finally for tangent, that is going to be the last one. This is the ratio of the leg opposite to the angle and the leg adjacent to the angle. So now you're not using your hypotenuse anymore. So we'll start with tangent of A, right up here. Okay. And so opposite to A would be side A. Okay. And then your adjacent side would be B, okay, because it's next to. And then for the tangent of B, okay, opposite would be side B, and then your adjacent would be A, so it just flips. Okay. Now, I am going to say you have to memorize these 3, but there is a mnemonic device to help us out, okay, and this is what I'm going to use from here on out, okay. What we're going to use is a mnemonic device, and we're going to write this down. Okay, it's SOH, okay, CAH, and TOA. Okay, and it's pronounced SOHCAHTOA. Okay, so how does that help us out? Well, here's the deal. The first letters of each one of these represents sine, cosine, and tangent, listed below. Okay. Then what ends up happening is the 2 letters after tells me what goes on top and what goes on the bottom. So sine would be opposite for O, so the opposite side, over h, which will represent the hypotenuse. Okay? So we have that. Okay? For cosine, it's ca, so a represents your adjacent side, okay, over h, which is the hypotenuse. I'm just going to shorten it like that. Okay. And then finally, for tangent, TOA, OA, that would be your opposite side over the adjacent side. So all we need to know is, using this mnemonic device, how to spell it, and then how that represents each one of those ratios. Okay? And this is what I'm going to use from here on out. Okay? Okay. So we're going to practice a couple. We have 4 examples, okay? And if any time you want to try this out on your own, feel free to pause the video. Okay? So I'm going to use that mnemonic device. So let's start off with sine of A, okay? Sine of A means I'm going to use the word so, S-O-H, okay? So what you have to really pay attention to is, where's your reference angle? Because that's going to be like, what's opposite to that angle? What's your hypotenuse? So I'm going to label angle A right there, okay? And for so, you're going to go opposite. So opposite to A would be 5 over your hypotenuse. Remember, your hypotenuse is always across from 90, so in this case it would be 13. And that's all you got to do. It's 5 over 13. Okay. For cosine, we're going to use the words ca, C-A-H. Okay. And so what I'm going to do is I'm going to erase my arrow first off. I'm still going from the same angle because it's cosine of A. So it's going to be the side next to for adjacent over the hypotenuse, which is 13. Okay. And then finally, for tangent, okay, that's going to be TOA. So that would be, tangent is opposite over hypotenuse. So opposite to A would be 5. Okay. And then your adjacent side would be 12. So it's 5 over 12. The order does matter, so that's a big thing. Okay. All right, we're going to switch it up, and we're just now going to do, okay, using now sine of C. So now C I'm going to label as my angle, and I'm going to go based on that. So let's start with sine. Okay, that's using so it's going to be opposite here, which would be 12, over the hypotenuse is the same as 13. Okay. For cosine of A, you're going to go adjacent to C, which is 5, over your hypotenuse, which is 13. Okay. And then finally, for tangent, that's TOA, so I'm using the same mnemonic device, but now I'm going to go opposite first, which is 12, over the adjacent, which is 5, and it's 12 fifths. Okay, so that's how we're going to do the rest of these, okay? Okay. Let's look at one where we have to reduce the fraction, okay? Okay, so the first thing is, either you can do this to the side, or you can do this in terms of the fraction, okay? If you wanted to reduce these sides, okay, what I could look at is this, okay? 16, 30, and 34, they all go into 2. So what I could do before I even start my ratios is I could just divide each one of these by 2, okay, which is perfectly allowed, and find those new values. So 16 divided by 2 is 8, 30 divided by 2 is 15, and 34 divided by 2 is 17. Okay, these are going to be, now you can cross these out. Okay, these are going to be my new values that I use. Okay, okay, so we're going to start with sine of Q. So start with Q up here. Okay, for sine of Q, you're using the word so. Okay, and then for cosine, you're using ca. And then for tangent, you're using TOA. Okay, so doing this, here's what I'm going to start with. Sine is going to be opposite to Q is 15. Okay, and then your hypotenuse is going to be that slanted line, which is 17. Okay. For cosine, okay, you're going to go ca, so it's going to be your adjacent side of Q, which is 8, over your hypotenuse, which is 17. Okay. For tangent, you can do tangent is opposite, which is 15 of q, and then adjacent would be 8. So it's 15 over 8. Okay. Let's switch up the angle. So now we're going to go to angle. It says sine of r. Okay, so that's going to be r down here. Okay. So now here's what I'm looking at. Is for sine of r, you're going to go, so it's going to be opposite 8 over your hypotenuse is 17. Okay. Okay. From there, cosine of r is adjacent, 15 to r. So 15 right here. And then your hypotenuse, which is 17. Okay. And then finally, tangent would be opposite. So opposite is the 8 over 15. Okay. And that's all we got to do. Okay, for these last two, here's the deal, is right now, looking at number 3, it looks similar, but the problem that you're going to have is that you do not have this side right here, okay? I can figure out that side. Guess what? It's a right triangle. I have 2 out of 3 of the sides. I can use a squared plus b squared equals c squared. Okay, so that's what I'm going to do first, and then I will go from there. Okay, so here's how I'm going to do this. So remember, C is opposite to your right angle, so that's C. And then A and B can be both 9 and 12. Okay? So I'm going to plug it in. 9 squared plus 12 squared equals C squared. Okay? And then we're going to simplify. So 9 squared, 81, plus 12 squared is 144 equals C squared. Add 81 and 144, and you would get 5. Sorry, guys. Let me just double check. Sorry, guys. My bad. 225. Yeah. That's C squared. So in order to get rid of a squared, you take the square root. Okay. And so C would be actually just 15. Okay? And so that's what I'm going to fill in to my picture. Okay, so now these are the numbers you're using. 9, 12, 15. Okay? All right, so here's how I'm going to do this. Let's start off with angle W up here. Okay? You can write your mnemonic device next to it. So it's so, ka, toa. Okay. So the first one, opposite to W, would be 12, okay, over 15. Now let's say you didn't reduce the fraction, okay, before you started these ratios. You could reduce that fraction. Just type in your calculator 12 over 15, and then it'll reduce it for you. It's going to give you 4/5. Okay, and so that would be your final answer. Okay. For cosine, it's ka. So it'd be adjacent, which is 9, right there. And then your hypotenuse, which is 15. This also reduces. They both go into 3. Be 3/5. Okay. And then finally, for the last one, tangent would be opposite, which is 12, over your adjacent side, which is 9. Okay. And so this would be 12 over 9 reduces to 4 over 3. And that's how you get those. Okay. Alright, I don't know if you guys noticed a pattern, but I'm going to show you guys an easy way of doing this. Let's look at the example above. Okay. If you look, do you guys see how, like, the diagonals here and the diagonals here, those answers match up? Okay. That's not a surprise. It's actually going to be true for all of these. So in other words, like, if we're looking here, like 4/5, if you go on the other diagonal, cosine of x is the same amount. It's going to be 4/5. Okay. 3/5 diagonal, sine of x is going to be 3/5. Okay. And then finally, for that last one, if you guys notice for this one, 15 over 8 becomes 8 over 15. So you're just going to switch the numbers. So instead of 4 over 3, it becomes 3 over 4. Okay. And those are all your answers. So it's maybe an easier way of doing it rather than doing it each and every time. Okay. Okay. All right, last one. Okay. So the last one, make sure that you have all three sides. In this case, you do not, so you need to use Pythagorean theorem. Okay. Always start with labeling C. C is always across from your 90-degree angle. So 40 is C. Okay. A could be 24, and then B is what we are trying to find. Okay. So we're going to use A squared, 24 squared, plus B squared. That's what we're trying to find, so we leave it, equals 40 squared. Okay. Okay. So then from there, we're just going to simplify. So squaring each, 24 squared is going to be 576, plus B squared equals 40 squared is 1600. Okay. And then from there, okay, I would subtract 576 from both sides. Yeah. You get B squared is going to be equal to 1024. Okay. And then finally, to undo a square root, you take the square root. Okay. So you can do this in your calculators. It's not necessary. You do it by hand. Okay. So the square root of 124, okay, is 32. So B is 32. Okay. I'm going to fill that in, and now I'm ready to go with my problems. Okay, okay, so let's start off with sine. So sine is SO of L. L is your reference angle. Okay. So from there, go opposite to L, which is 32, and your hypotenuse, which is 40. That does reduce, so 32 and 40 both go into 8, and so this would end up being 4 over 5. Okay, actually again. Okay. Cosine of L, okay, go adjacent, which is 24, over your hypotenuse is 40, okay, and so that would actually be reduced to, they both go into 8, be 3/5. And then finally for tangent of L, that would be your opposite side, which is 32, over your adjacent is 24. Both of those go into 8, and so that would be 4 over 3. Okay. Okay. And so what you're going to do is the little trick I showed from before. Diagonals match up, and this is the reciprocal of that. Okay. So in other words, this up here would be 3/5. This down here would be 4/5, and the reciprocal of 4/3 would be finally 3 over 4. And those are all three of your answers. Okay. So I know that was kind of quick, but if you want, like, I'll post these notes on Google Classroom in case you want to look back at them. But yeah, that is it for the lesson. Okay. Well, homework I'm going to ask you guys to do is the lesson. It's going to be 8.2, day 1, Delta Math. Okay. And I will check that in when I get back next week. Okay, so all these assignments, I'm not going to check in until next week, but, like, you don't want to overwhelm yourself. Okay? If you guys don't have anything else, feel free to sign off. Thanks.